Hello and welcome to today's webinar, Don't Let Your Design Data Manage You. And my name is Brittany and I will be your moderator for today. Before we get started, I'd like to address a few logistics and details on the GoToWebinar platform. If you're unable to hear the presenter or see the presentation at any time throughout the webinar, please let us know in the chat. We'll do our best to resolve any issues. If you have any questions throughout the webinar, please type them in the questions panel as they come up. We'll have representatives ready to answer your questions directly during the webinar. This webinar will be recorded and posted on the EMA resources page. Once this is posted, we will send everyone who is registered for today's webinar an email with a link to the recording in the next couple of days. That said, I want to thank you all for joining us for today's webinar and introduce you to our presenters, Jeff Iams and Mark Caradonna. Jeff has a diverse background based around the ECAD arena for the last 30 years and now focuses on data management, custom services, and a wide range of products addressing the overall solution EMA provides to its customers. Our second presenter, Mark, has 16 years of ECAD experience and now works for XPLM as Director of Sales and Business Development, maintaining relationships and assisting PLM providers and customers with ECAD integrations. We'll start off the webinar with an overview of data management and some common examples, followed by a brief demonstration. Thank you for your attention, and now over to you, Mark.
All right, thank you. Let's go ahead and get started. All right. So who are we, right? EMA, founded in 1989, the North American exclusive reseller of OrCAD products for Cadence. They also have a dedicated team that does software development and builds products like OrCAD EDM, for example. XPLM, we were founded in 2005. And if you hear XPLM, think ECAD and MCAD integrations. It's what we do as a company. We build CAD integrations to various PLM systems. So I'll be doing the slides and then I'll hand it over to Jeff, who will be doing the demonstration. So some of the market trends and like what's going on out there in the marketplace today. Lot size of 1. What does that mean? So it means you have a customizable, configurable product, and that is a configurable product that's not only for one domain like ECAD configurations where you have variant boards. It could also be mechanical or software. And how is your company managing all these different variations of a single product to meet, the needs of a specific customer? Another trend that's out there right now is interconnection with IoT, Internet of Things. This picture right here is a pretty cool example of someone using an iPad to show some thermo overlay over a real life operation out on the shop floor. You can imagine, maybe not this year, maybe not next year, but a few years from now, you could have this same iPad showing you a printed circuit board and a technician's able to identify where the short is with the instructions how to remove the broken component or something like that. But you're not going to be able to realize that if your intelligent ECAD data is not in a system that can then be connected to an IoT type platform. Another market trend is just the higher product complexity. You have more and more electrical and electronic components in products. And the easiest example there is your car. Years ago it was just a mechanical contraption, maybe some wires in it. Over time, there's more electronics and even more software in a car now than ever. And it's just going to continue to increase. So more products have more electronics, therefore we need to manage this data somewhere. So why integrated data management? Why should you care? And what is integrated data management? To me, that can be one of two things. It's taking your CAD data that's on your desktop and managing it in a WIP type environment like a OrCAD EDM. But it's also managing that CAD data in a version controlled PLM system as well. So I'd consider this to be kind of the combination of those two things. And when you do put them together, you can realize, a number of benefits here, and you can just read these statistics. I'm not going to read them off one by one. But the whole idea is that if you are using a proper integration between your CAD tool and these WIP and PLM release systems, you can reduce the number of manual steps required to get your data into those systems, right? And those manual steps, they take time and they're error prone. And that was, by the way, those statistics came from an Aberdeen study. That's not something we just came up with. So unique ECAD data management challenges. What are some of the challenges you guys face on a daily basis or weekly basis? We'll start in the top left here with inaccurate or incomplete production data. Well, if you have a proper integration in place, you have defined and automated processes. So with defined processes and everyone doing the same, all users performing the interaction with the PLM system the same way, you can guarantee that will be by other people. Inefficiencies due to unnecessary search or repeated work. So you couldn't find a design, so you rebuilt something. You know, with PLM search and the structured content we just talked about, it's easy to find data inside the system, bring it back down, and work on it. You can use it as a starting point, or you can make a Rev B of it. Errors and inefficiencies due to manual data maintenance. So instead of manually updating a BOM to a PLM system, how about we automate the generation of that BOM? Automate the generation of the additional files that get created along with your BOM, such as your manufacturing outputs. Make it as simple as possible to get the information needed outside of your engineering group into the system. Data is lost. It is really tough to lose anything once it's in a PLM system. We're not talking about file systems where you're taking your .brd file and renaming it to underscore rev b, underscore rev b-1, underscore rev c. This is a proper database system that's tracking all the revision control data. Library data getting out of sync and getting duplicated. Well, with a PLM system, we have a library synchronization. It's going to synchronize what's in your CAD library, your CIS, CIP library, with the part data inside of PLM. It's going to keep your information in both systems up to date, automatically, without manual entry required. Risk through outdated design data, right? If you're using a PLM system, it's under version control, and it's pretty hard to not use the right latest release of the data to work from. Several development methods impeding collaboration. We provide a consistent approach with templates, and every time we check in data to PLM, it's using the same data model. So all your designs that end up in the system will be the same model, and these templates make sure that there's a consistency in the way that you're designing every design. Last but not least is managing change. How is change managed? When you have a PLM system in place, your engineering change order has a link in the PLM system to your CAD data, to your CAD parts, so that a change is actually being done with this relationship, and it's all being tracked. All right, so what is the ideal integrated ECAD environment? What does it look like? Here it is. So we've got our PCB engineer over on the left side here, and he's working off his centralized part library in his WIP design data management system, okay? And if there's a part that's not in his library, he's got his online content sources that he can bring that information down and start using it. So this is your WIP side, and over here, here's our release to manufacturing and all of our PLM systems listed. And the integration is right here between these two systems, right? Keeping this data over here synchronized with the data inside the PLM system over here. So we support a whole bunch of different PLM systems today. The focus is on PTC's Windchill PLM, and you will see that in the demo. One step deeper of the integration, so over on the left side, we have our Cadence OrCAD. On the far right side, we have our PLM system. In the middle is the Enterprise Integrate. These are the functions that the Enterprise Integrate offers, and the way the XPLM is capable of supporting so many different CAD tools and PLM systems that we do is with this connector infrastructure where we can have a different CAD connector and a different PLM connector. So what does Integrate offer? We can create new ECAD projects directly from within the ECAD tools. Then we save them to the PLM system. And all the check-ins and checkouts happen for the user. Basically, we keep you as an end user inside of the CAD environment. You do not have to leave the CAD environment to invoke the integration, which is a huge benefit. And you can open a design that's already inside PLM, bring it down, make some changes to it, and check it back in. It allows for faster creation of your BOM structure because we're going to generate the BOM, and that could be variant BOMs as well. We handle variants very nicely with the integration. Any sort of derived data like your manufacturing files, IPC 2581, an assembly drawing, a fab drawing, anything like that, and even viewables like a Creo View viewable can be generated as part of the integration and pushed into the PLM system. We also offer a BOM comparison. It's going to give you an idea of how healthy your BOM is, comparing the BOM that you're trying to check in to what already exists in PLM. And last but not least, title block updates. We update the title block in your schematic during the check-in process so that if you're checking in, let's say, a PDF drawing and that has a drawing number on it, we'll make sure that that drawing number, which is a PLM number, is in your title block and is at the right rev, so that when you're looking the version control data, when you're looking at it and pulling it out of PLM and you're looking at the PDF, you'll see that the version matches what's in the PLM system, which is very nice. And of course, part synchronization, keeping your parts up to date from your CIS CIP library and your PLM system. Let's say inside of PLM, a part is marked obsolete. How do you make sure that all your engineers are no longer using that part inside of their OrCAD designs? That part of obsolete state makes its way down into the OrCAD libraries, and users will see is an obsolete part. Just one small example of how that data being fed back and forth between these systems at the part level is critical. All right, and then I'm going to hand it off to Jeff. But just keep in mind, as you're watching the demo today, notice how the integration does keep you inside of the CAD tools, and the integration to PLM is invoked from within the menus.
All right, thank you for the great information, Mark. And Jeff, I'm going to hand it off to you, and you can start your demo.
Thank you very much, and welcome everyone to the demo portion today. My name is Jeff Imes. I'm going to go through and I'm going to walk through how this integration really works. And as you go through and you'll see me operate with the applications and the integration, you'll see that it is very easy to use. And I think that's what I really want to stress. So the last thing you want to do is, we have very complex designs we work on. We don't want to add in a layer of complexity just to be able to do this kind of data management. Okay, so first of all, in the OrCAD environment, okay, so I'm gonna be in the OrCAD environment, but again, as we go through the demonstration, I'm also going to bring up and show you how this data looks inside of the PLM system. And today, what we're doing is we're using Windchill from PTC. Okay. Now, this is a live connection. Okay. So again, you're going to see things operate in real time as we go through this whole process. First of all, within the environment, I think this is something that is going to be very important for users, especially when they start diving into this whole data management aspect, is that in the OrCAD environment, we have a total WIP, a WIP experience. So again, the importance of that is we're going through, we're doing sandboxes of our design. We are doing sandboxes of our designs and when we're trying to go through the whole process of making sure that we can capture every bit of our IP or as we go through and we do our designs. And you notice immediately that inside of OrCAD, I can very easily get into projects. Okay, I can see the projects, I can see iterations, I can see revisions, I can see all the projects that I'm associated with. Now, due to the length of the demo and the time here today, I'm not going to go into too much detail around this, but I think the overall aspect is that in the OrCAD environment, you can vault the data, you can check in, you can check out, you can assign users, you can assign team-based type of designs, you can manage your libraries. Overall, what it's really doing is it's giving you that dashboard or cockpit that you have access to all the projects that you have permissions to interact with. Okay, so and again, as we go through and we look at these designs, we can see that not only are we managing an ORCAD capture design, but we're also managing even the board or the PCB editor board file. Okay, now the design I have today is already loaded. It's a project that has a schematic, and it has other files associated with it, like the PCB. And also we're gonna show how the integration is gonna build and put this all together for us. Now, in the ORCAD environment, you can do bills of materials. Okay, so if you need to do prototyping and things of that nature, you could do that. Okay, we're not limiting that in any way, shape, or form. We give you all that flexibility, but at the end of the day, there's going to be certain milestones that you want to hit, and you want to achieve this kind of way to collaborate that information or make that information available to the PLM system. And I'm going to go through and show you how that's done. So first of all, like what I can do is I can open up a design, and we're going to work on a schematic, and we're going to make some changes to that. Okay, so this particular schematic design, what I'm going to do is I'm going to create a brand new component, and then I'm going to show you how we can do that very easily, and we're going to make that available in the PLM system. Now, one thing about all of the interaction that I'm doing today, as Mark was saying earlier, this is extremely configurable. So if you have some processes, and we have starter processes or packages that allow you to get to a certain point, but we have the flexibility also to be able to incorporate some more processes around if your processes are require additional capabilities. So we have lots of experience in that area to be able to achieve that. Now, so first of all, what I'm going to do is let's use our distributor search, and let's go through this whole process. So I'm going to create a 3.5 picofarad cap, and again, I'm creating one that's I've got a lot of parts in my database, so I'm sort of hoping that, I doubt if a 3.5 is in there, but we'll go ahead and we're going to search for that. That's a live link. I'm going out to the distributors now, and in the ORCAD environment, we can even go beyond that with our compliance module. We can go through that whole process if we wanted to go in and search for much more compliant information, like obsolescence or any kind of life cycle information out there. We can do that. Okay, so we have that capability, but for this demo, I'm going to go ahead and search it. You'll notice that I have a component. I'm going to go ahead and select the component. This is going to give me the information initially that I want to research. Okay, now remember, I'm going to create this in ORCAD, but eventually I want this to get over to the PLM system. So I'm going to go ahead and I'm going to create this as a new part. So we handle NPI, or new part introduction, very nicely. It's very powerful, but it's very simplistic. Okay, so we want to take that element of this whole finding components, copying and pasting, making errors. We want to get rid of that, and this is how we're doing that. Okay, so we're leveraging data that's already abundant out there, like lots of parametric data fields. Okay, so we're going to go ahead and we're going to create that. Once I create that, the next thing you're going to notice is that we have this temporary part. Now, can I do certain things to this part? Maybe I want to make some changes to this. Let's go ahead and do that. We'll do that quickly here. Say, for example, I might only want the package to be an 0805. And you can see lots of benefits to using a system like this, because you can start seeing ways that it's helping me keep things consistent. And again, ease of use. All right. And as we go through, we might want to be able to make things simpler but make them consistent. You'll notice that maybe I might want to actually fix up my maximum temperature. I'll go ahead and make a change here, and it might be -55°C. I can leverage that. And then after I'm done that, these are more ORCAD related functions. Maybe not PLM specific, but if I want the part type for our users in OrCAD, we can easily create that. And we can also maybe standardize on the description. Now, the nice thing about this is that you might standardize on the description in the PLM system. What you're going to notice is I go through and I make these kind of adjustments, and I add these to the PLM system. We have a bidirectional flow, and you'll see that immediately. And I want you to recognize that we don't have a revision from the PLM system, and we don't have the company part status that's actually coming from the PLM system. So this is even unassigned in PLM. So we'll take a look at that. Okay, I'm going to go ahead and the other thing is that we also don't want to inhibit a user to say, hey, I've got to get this design going. I don't want to deal with the PLM system right now, but I want to just continue my design. You can very easily do that. You can go up here to place or preview a part right within the OrCAD environment, and I can go ahead and I can play to help facilitate this whole demo, and so you can see what's really happening here. I want to explain about what we do in OrCAD first. Is say, for example, I place my component in my design. Now it's being tracked as a temporary part. It's not a release part in any way, shape, or form. It's just being tracked in the ECAD space. Okay, so let's go ahead and do this now. Let's go back to where we saw our part. This time what we're going to do is we're going to convert to PLM. When we do that, you're going to notice that the temporary part, number 35, it's being tracked in our schematic and controlled that way. Okay? Eventually, what we can do is we now have a qualified PLM part number. This is in real time. This is going out to Windchill PLM and bringing this back in as a part number. This part number can be classified. This part number can be simplistic. However your PLM system is, our configurations that we do with the integration will capture all that information for you. You'll also notice, remember I said earlier that we have a bidirectional capability. We're writing data out, such as maybe pertinent type of parametric fields, okay? And that might be including the manufacturer information that we downloaded. Or, you know, we can see that we want to get data back from the PLM system, but we also want to make it easy to get it into the PLM system as a preliminary part, okay? Now, the other beauty about OrCAD is that we go through and say, for example, we want to see what's going on with this temporary part. Might be a day, might be 2 weeks. I don't know, but we have all the capabilities to check it. And it will automatically let us know that, hey, my temporary part is now an approved OrCAD part, okay? Maybe its PLM is different in its aspect, but it's an approved OrCAD part. Now, at this point, what we're going to do is we're sort of going to switch a little bit, because now we notice this part number is, and let's take a look at this part. It's 2084. So we're going to look at what happens with this new part that we introduced. Now, back in the schematic, let's do a couple other things. Let's delete a part. Okay, so we're going to delete C16, and we'll just let this float out there for now. And then I'll go ahead and save this off. And next thing I'm going to do is I'm going to invoke the integration, okay? Directly from OrCAD. I'm not going out to any other tool. I'm doing this directly inside of OrCAD. I can select a new project. By the way, my project's already been, so the way that you can think of this as an operation is that you could create a new project, and then you could even open a project from PLM, or you want to go through and you want to save it. So think of it this way. We go through this process, and we can initially start to go into this whole area where we have milestones and iterations, okay? Maybe we want to do a quick bomb to send over to purchasing. the purchasing operates out of a PLM, for example, or you want to generate a BOM directly from OrCAD. You can do all that. So you give all those kind of capabilities and you have that flexibility. Immediately, what you're going to notice is that we track all the information. We can create the innovation document. Also, different PLM systems have different approaches, but they're going to be a very similar approach when it comes to interoperating with the PLM system. So again, it's going to be very similar what I'm showing you today, even in a different PLM system. Again, what we can do is we can create ways that we can send that design data, PCB data, schematic data, the bill of materials, the assembly data. We can do all of that and make that available. We can even select what we want to go in. There's through the configurations, there's initializations. There might be more files that you want to do, or in a simplistic approach, I want to do it the same every time. And I think that's probably the biggest message I have. And when I was designing, I don't know how many users out there are familiar with like README files and Gerber files and how do they look, and you had these templates and took time. What we're trying to do is we're trying to take those 8 hours out of the day that you can use for something else and do this in minutes. Okay, so it's virtually very easy to do that. Again, next thing I'm going to do is I'm just going to go ahead and select the core design. We can support variances, but in this case, I'll just do the core design. And you'll notice what I have checked off here, and we'll go through that process. Now, one thing before I invoke it, if I go back to the page, one thing I want to point out is that, so when you check in and you check out anything from the PLM system, and you'll notice that here is my main number that's coming directly from the PLM system. Okay, so now you have a title block that's being automatically generated. Again, taking all that manual intervention and that error-prone process out of the picture. Okay, and Mark mentioned that earlier. So let's go back. Let's go back here. Let's run this. Let's go ahead and bring it up. So we're going to go through and create some documents here. Go ahead and let this run. Now, the important part about this is that I have data, I have parts that are already in the PLM system that have been integrated to OrCAD. So they're synchronized. They're 100% synchronized, and this synchronization occurs. Okay, so if something changes its obsolescence, you're going to see that. In the case with the integration now, we're uploading a bill of materials. Now, so the important part is it's actually pretty slick, because you do get redlining. You can see, hey, Jeff removed a component here in this schematic, and he also created this new part in the database. Okay, so we'll go ahead and we'll let this push in, and it's running through its process. I don't need to touch anything on it. Continue to run. Remember, I'm doing this in real time. I'm actually updating the PLM system. I'm ECAD centric right now. I'm not in the PLM system all the time. Like Mark was saying earlier, it makes it so that you have that interaction with the PLM system directly from the ECAD, in our case, the OrCAD environment. Okay. Now, what we can do is, let's just go ahead and examine the data in the PLM system. Well, we can go directly to show, and that will invoke a browser for this particular design that we have. I can feel confident that my part data is there, but let me go ahead and show you the part data in the PLM system. Let's look at the structure. So I am in the core design. That means that this is going to be that assembly or that top level area for your board. Okay, so we'll go ahead and we'll look at the structure. And what we're going to notice is that there's that 3.5 picofarad capacitor that I generated. And if I want to view that, I can go in and I can see the details of that part. I can go in and see that what the version of that part was. It's what the status is. Let's watch this right here, because we're going to come back to this. So we can actually update the PLM system if it's in a certain life cycle, like in work. So we can continue collaborating back and forth with this part data, and we'll see how this works a little bit later on. But again, that's that part. And then you can see other things in the structure, say for example, like the PCB. So this is all being automatically generated. So in that structure, we can see the PCB. We can navigate to that if necessary. We can see all the related objects. When I look at this related objects, I can see, whoa, there's my CAD documents, right? This is my CAD data, okay? So if I wanted to navigate to it, and you can see it gives it a number as we go in, I can navigate to it, okay? And I can check the content. And I think this is where I would need to understand how to access that in PLM, but I'm showing you that today so you can see the data. I can download specific data, and here's the design data. Okay, so I didn't have to go out and zip anything and put it on a drive, put it in a folder, crossing my fingers and hope I have the right folder. Go to PLM, check in, create the project in PLM, do all that. Now I have that kind of simple, easy to use methodology. Okay, and there's the board file, so we can definitely see the advantages there. The other thing that we have is like even the PDF file. So again, you can immediately see there's my data, and I didn't have to go out and say, okay, go to file, print, and same kind of process I just said with the files. So it has lots of advantages. Okay, even automatic population, automatic generation of PDFs, going through that whole process. I'm not a Windchill PLM expert, but the important part is I don't have to be. Okay, I know I can go in if I want to navigate to my PCB. I can do that. I can go right to the PCB. I can go to related objects. I can select the PCB. I can go in and I can see the content of that. I can see there's my Gerber files. Again, I'm depending on what you want to configure. Here you can have Gerber files 2581, the IPC 2581. It's even a very powerful format, that OrCAD can provide. So again, gives you a lot of capabilities there. Back in the 2081. We can also see any of the related objects that we had, say, for example, the assembly or that top level information. I mean, we might have assembly information too. Again, go to the content. Here you can see all the hierarchy is automatically done for me. So if I want to have assembly drawing, like pick place files, I can have that, right? And this is all automatically generated from what we have in OrCAD, even the design in the board files. Very powerful. So the next thing I'm going to do is let's look at one more thing and we'll finish up this portion of the demo. So when we're inside of, let's look at a part here. Let's go back to our part. And now what I'll do is I'll go back to my structure. As we go through and we look at the structure of this part and the assembly, there's my 3.5 picofarad cap. Let's do one more thing here. Under the details, you're going to notice that this is, let's say 125, the temperature is 125 centigrade and minus 55 centigrade. Right from within the OrCAD environment, I can go in and edit and make those kind of changes. Whether or not you want to make those changes or not, but I think it's important that you understand that we do offer that kind of bidirectional capability. Select PLM part update. Back in the PLM system, if we were to go through and refresh this, now you can see that what we can do is we can drive it. Earlier I showed you how we can drive data back from the PLM system into OrCAD, and then we can also go from OrCAD to the PLM system in a very simple bidirectional flow. There's a lot more capabilities. I'm going to go ahead and hand this back over to Mark so we can put up another slide there. But I think it's very important to understand, that this makes it a very simplistic kind of approach. Thank you very much. So what are really the reasons to integrate for certain roles in the development ecosystem? And to summarize all this is really the importance of this. And really for the electronic developers, the integration is going to save time in development, and it's through the automation transfer of electronic data and BOM from electronic CAD and PLM. Also, you're going to avoid those mistakes during data transfer to PLM, as there is no user action aside from the responsible engineer. And the acceptance of PLM improves through an easy-to-use interface, and that's going to be minimal effort required to manage PLM relevant design data. Okay, for the product developers, the integration really accelerates the product development through the creation of electronic BOMs and CAD data transfer between the electronic and the hardware development. All right, you have improved quality of the development process as a result of the full integration of the change management in that electronic development process. And you increase the transparency in the development process as the design data is available to everyone involved in the project. Finally, for corporate IT, the integration saves money by using the available PLM infrastructure and system administration. It also secures IT safety, which is very important, with the ability to manage the access, data protection, and the complete system administration tasks, both centrally and across other business locations, to reduce heterogeneous system landscapes and the effort required to maintain them, like waiting times and user support, interfaces, and administrative know-how. Okay.
It looks like we have a bunch of questions still coming in. Unfortunately, we're out of time for today. However, if anyone has questions that were not addressed during the webinar, we will be following up with you on an individual basis. I will be closing the webinar now, and we will be sending everyone a recorded version of today's webinar with a slide deck within the next few days. Thank you for taking the time to join us today, and enjoy your afternoon, everybody.
All right. Thank you.
Thanks, everyone.